Hi guys, performing further tests with universal indicator. Here I am pouring some universal indicator into a beaker, a very small quantity, and now I will be adding distilled water to it. So as you can see, we have the green color turning into a blue green color because we've added a very small quantity of the universal indicator solution. To this I am now going to add a little sulfuric acid. Look what happens when I add sulfuric acid. The solution turns red. This is the color of universal indicator in acids. So now I will follow this up by diluting it further. The red color remains, and now I will follow this up by addition of sodium hydroxide. Now when I add sodium hydroxide, the universal indicator is turning purple, and here it is with the purple color. This is the color of the universal indicator in bases. So now what would happen if I re-add some sulfuric acid? Let's see. So I add a little sulfuric acid and you can see the purple color changing back to the red color, and when I shake it, all of the purple color disappears and the red color reappears. And let's repeat this with addition of sodium hydroxide. When I add a little sodium hydroxide, as you can see, the pink color is now again changing to purple, blue purple. Here we have the purple color appear again because the sodium hydroxide is now in excess. Let's add a little more universal indicator to see what happens. We have added 5 drops. When I shake it, it still stays the same color. So the color that we observe with a few drops of universal indicator is the same color we have observed with the universal indicator in a larger quantity. Here we have added a lot of it in excess, so the color turns deep purple because we have more universal indicator present. So now let's do the sulfuric acid and ammonia tests again. Adding sulfuric acid, not ammonia, sodium hydroxide. Adding sulfuric acid, the purple color disappears and the red color is deeper now because we have more of the universal indicator in this solution. And finally adding sodium hydroxide. First the acid will be neutralized, which you can see happening, and then after the acid has been neutralized, we will get back the purple color. Here you can see that finally the acid present is being neutralized. Okay, our beaker is full. I'll transfer this contents into another beaker so that they are mixed. As you can see, just look at this difference in color. We've got red color at the top, green in the middle and blue at the bottom. So the solution at the top is acidic, the one in between is neutral, and the one at the bottom is basic. So this is something new that has just happened with the universal indicator. Now let's transfer this solution into an empty beaker. So you can see the different colors that are forming. This is because the pH of the solution is constantly changing as more and more of it is being added to this beaker and the contents are being mixed more properly. So here we have a green solution. This pH is close to neutral. Now we are adding the purple solution into the green solution. Look what is happening. The color has changed from green to blue green, and when we add more of this, the color has further changed to another shade of blue. And now adding more sodium hydroxide to this, we get the purple color. So in order to mix this again, let's transfer the contents into the first beaker so that it's mixed properly. Look at the color changes happening in the beaker as the solution is constantly being poured. So it's gone to blue, and from blue it's going to purple. And this is the final color that we have achieved when sodium hydroxide has once again become in excess. So it is a fascinating indicator, the universal indicator.